what does trigonometry mean? What is trigonometry?
It's to do with triangles.
That's exactly what it is. So in short, trigonometry is the study of triangles. So it's to do with, and there's different types of triangles. On our course, I suppose we do distinguish between the two triangles I've drawn here. One of them is an easier triangle to deal with. Can anyone tell me the difference between the two triangles, or one difference between these two triangles? I'll call this triangle A and this triangle B. Does anyone know?
It's a right angle.
Very good. So B is what we call, it's called a right triangle. Sometimes it's referred to that, or a right angled triangle. On our course, mostly it's the right triangle that we deal with, and the other one is just called a non-right angled triangle, or non-right triangle. Okay, so just to say that these are the two types of triangles we're going to deal with. So today I'm going to concentrate on the right triangle. Now there's some things we already know about right triangles. So I'm going to ask you maybe to solve this puzzle here, for instance. I'm going down 3, I'm going across 4, and I know that this is a distance 3, and that is a distance, this other side is a distance 4. What question do you think I would ask you?
What's the area of the triangle?
Very good. I could ask you that, and that's a very fair question. It's not the question I'm thinking of, though. You could
What's
be.
the length of the hypotenuse?
Very good. And there's some good language here already. So what we know in a right angle triangle, so this is a particular case, the long side, the side across from the 90 degrees, is called the hypotenuse. So that's what we call the long side in a right angle triangle. So if I was asked you to find the length of the long side of the hypotenuse, how would I do that?
It's the square of the two others.
Very good. Whose theorem are we talking about there?
Pythagoras.
Very good. So Pythagoras, his theorem states that the square on the two small sides, so I square 4 and I get 16, square 3 I get 9. What do I do with these two squares? How does it relate to the square and the hypotenuse?
Add them and you will get the square root of the hypotenuse.
Very good. So add them together, and the square on this, the side then would be the square root. So this here must be the square root of 25, which is equal to 5. Okay. So in terms of trigonometry, I suppose the first and most important thing to know about trigonometry, about triangles, is Pythagoras' theorem. And right up to Leaving Cert, that's going to be the rule that we use more than any other. And we might have seen that we used this when we were doing, say, the distance formula in the line. So that's Pythagoras' theorem. He didn't do it in algebra. There was no algebra as we know it now, really, when he was working. He stated in words that the square and the hypotenuse is equal to the other two squares added together. Sometimes you might see it, though, written in algebra form. In algebra, it looks something like this. A more formal way of expressing Pythagoras' theorem using an algebraic formula would be to say that b squared plus c squared is equal to a squared, where a is the hypotenuse. Two triangles are similar if they have the same angles. All three angles are the same. If this is the case, well then the sides would be in proportion. So if I compare the two triangles I've drawn here, if one had a side 3 and the other side 6 in the corresponding place, well then the 5.5 must also be doubled to 11. So the second triangle, the sides in it are twice as big than the first. Because this is true, that their sides maintain this ratio, we could work out what angle A is based on the ratio. And the calculator are just books with tables that will tell us what angle A is if the sides are 6 and 11, or 3 is to 5.5. So this is where trigonometric ratios come in. We call these ratios sine, cosine, and tangent. Compared to angle A, the opposite side is the side across from A, and the side that's touching A, that's not the hypotenuse, is called the adjacent side to A. For shorthand, we'll call the hypotenuse H, the opposite O, and the adjacent side, side A. We would like to work out the ratios for cosine of A, which we call cos A, sine of A, which we call sine A, and the tangent of A that we call tan A. The formulas for these are easy to remember. Remember the phrase SOHCAHTOA. So the phrase we use is SOHCAHTOA as a way of remembering the formulas. So what these mean are sine A is opposite divided by adjacent, cosine A is adjacent divided by hypotenuse, and tan A is opposite divided by adjacent. So these are our ratio formula. These need to be remembered. If in the question here we are told that the opposite to A is 3, the adjacent to A is 4, and the hypotenuse has a value of 5, could we work out the fraction values for the cosine of A, the sine of A, and the tan of A? Cosine A is adjacent over hypotenuse, 4 over 5. Sine of A is opposite over hypotenuse, so that would be 3 over 5. And the tan of A would be opposite over adjacent to A, which is 3 over 4. So these are the ratios for the cosine, sine, and tan of A in the triangle that I've given here. Later, we will learn how to use these ratios to work out the value of A using the calculator. Your assignment before the next class is in this given triangle here, that is a right angle triangle with sides of 5 and 12, 5 across or opposite to A and 12 opposite to B. Firstly, we're to work out the length of the hypotenuse, that's the value of x. Then I would like you to work out the ratios for sine of A, cosine of A, and tan of A. And finally, the ratios for the sine of B, cosine of B, and tan of B. And leave your answers as fractions.